Welcome to the Battery Testing Mentor podcast. My name is Johannes, and here I discuss all topics around battery testing, battery safety. Short, on the point, and with actionable advice. Also, visit www.batterytestingmentor.com to sign up for this summary where I can send out what I talk about. And if you have any questions, feedback, let me know. Just hit reply on this email and you can directly reach me. Today, I have another kind of very live, very actual, very up to date topic. I was in the last couple of days at another conference exhibition, and I want to share with you the insights that I had. This time it's a little bit different. A couple of weeks ago, or was it even a month ago or even longer, I was at a conference that was very scientific, very technical, very detail oriented. In the last days, I was at the battery show in Stuttgart, and that is a huge exhibition affair. And there's a conference there where I also was fortunate to make a speech about safety of aged batteries, especially when you look into second life applications. I come to this later. First, I want to share with you the insights that I got there from talking to a lot of people that I knew from previous times. Also, a lot of friends from my China time that came there. And then I will give you a short summary of what I found out for my talk. I said it's not so scientific. So there were really a lot of speeches, a lot of things about the general battery development. Where is the battery industry going in the different areas of the world, the different regions? And I mean, it's not a big surprise that China is, of course, leading the battery industry, dominating it. It was also super interesting to see there on the exhibition that a lot of the booths that from Chinese companies had such a big blue banner on top that said China, and there was a battery, and like everyone the same. So you could really walk around, and around every corner you saw another banner with China mentioned on top, and you really saw how present this battery industry is from this Chinese point of view. Um, I talked to some people there, and I found out that the reason was just that Chinese companies, if they come from China and book it from China, they need to go through a distributor there, and this distributor just made this China banner on top of the company booth. Yeah, but it was really interesting to see, the presence, the weight that Chinese companies play in this industry. And then there are the other two big regions, Europe and US. And in the last couple of years, you always thought, oh, the US is lagging behind. It will take another, like, it's 5 years behind Europe. Europe is kind of trying to catch up with China. At this conference, really, it was interesting that most people said Europe is starting to lag behind because the US put this IRA out, the Inflation Reduction Act, where they support battery industry extremely. I mean, they also support other things, but especially the battery industry, and that really gives them an advantage compared to Europe. And a lot of companies are canceling their European plans to move to the US to build it up there because they just get a lot of subsidies. And there are three main reasons for the decision. And one is the subsidy. The other one is the general cost basis. And the Europe is also not that good with the high energy prices at the moment, then high labor costs and so on. And the third one is raw material supply. And here, Europe has really an issue, basically. Put it very, very bluntly, it's very hard to get raw materials in Europe. It's basically impossible to build new mining sites, new getting the raw materials out of the ground because of these extremely high requirements to get a permit. It takes a very long time. And it was really sad. Companies that investigate the different mining opportunities, why should they even spend the time to do this in Europe if they can go in another region of the world and get it there much faster? Um, and this will, of course, have an influence on the battery industry, the battery production, because if the raw materials are not so easy to get, why should you build an battery factory there? And it was also super interesting. One person there, I need to look up the name, but said, especially in this raw material supply chain, that lithium travels up to 160,000 kilometer or 150,000 kilometers from the mine until it really is in the car here on the road, because it goes from the mine to one processing plant and then to another and then to another, and often then every processing plant is in a different country. And it is possible to reduce this transport to be below 1,000 kilometers, but that means, of course, you need the mining around this area, you need the processing in this area, you need all the process step in this area, and then the production of the battery also there. And yeah, this was really kind of eye-opening to see that Europe has some homework to do, let's call it optimistically, to really not fall behind China and US. Yeah, and going now from this high level to something more connected to the real battery is the new materials. Of course, you don't talk so much about what is existing, but about what is coming up. And as everybody would expect, sodium ion was the big talk of the town. There were a couple of speeches, I don't know, even five, 8, 10 speeches about sodium ion, or they touched sodium ion batteries. It is definitely a very interesting topic. What impressed me was an talk by, I think it was a Fraunhofer Institute that did a study and looked at, kind of where can sodium ion be applied. And because it has some special properties, it has a lower energy density, so it cannot really be like the next battery in a Tesla Model S or so. It needs some specific applications where you get along with lower energy density, with not so big battery packs, not so much energy inside. And if you then map this out, they get to a market share of around 15% that is possible in 2030, where sodium ion can really capture this. And 15% is quite a bit. But it's also not like, oh, it will be the next dominant battery, right? So the other point is also that 15% is a lot, because they said you need more than 10 gigafactories to just produce the sodium ion batteries. And so far, there are not these announcements that these factories are coming online, and 2030 is basically around the corner. If you talk about a new gigafactory, you need around 4 to 5 years just to develop this factory, to build it, to get the permits, to start operating. And then you need another couple years to ramp it up, to really get an output that is close to what you have as the target. So this was interesting to say, okay, there's somehow this announcement, but there's not this match in the production planning. On the other hand, I thought then this sodium ion is said to be such a drop-in technology that you can just produce on existing lines So it seems, if this is really the case, then it seems to be rather easy to replace existing lines, kind of take out the lithium and put in the sodium. And the other thing, what was also interesting, is that most of the announcements, most of the companies that work with sodium ion are in China. There are tens of companies that want to develop, are developing, are starting to produce sodium ion batteries. And from my experience in China, I would say it was always a little bit surprising how suddenly developments happen there. So it could very well be that we are just not aware outside of China about the developments there. And maybe there are already 5 gigafactories in planning for sodium ion, specifically for sodium ion, that just nobody knows about. But this is really something we will see. Also interesting from the other side, new technologies. The silicon anode was highly discussed, especially like not pure silicon, but adding silicon to the graphite. And by this increasing the energy density. There were super interesting figures where you said if you add 10% of silicon to the anode, you can reduce the graphite content by 50%. That means you can put everything closer together. You reduce the thickness of the layer of the anode. And by this, the cell gets a lot more energy dense. And in the end, you basically can reduce the amount of cells by 25% in a battery pack. One issue with the silicon anode is that the lithium content per kilowatt hour needs to be higher. And this was also discussed, like, how do we secure the raw materials? There was this spike in the lithium price last year. If we go to these chemistries that require higher lithium content, it could be that we get into these high prices again. For example, if we go to silicon anodes, but especially if you go to lithium metal batteries, where you have a lot more lithium inside that than now, where you have basically the lithium just in this, like, in yeah, compound form. So in the third really interesting thing was, of course, cell to pack discussions. Basically, what I understood, there are three key components when you look for a cell to pack design. It's the cell selection, the safety, and the structural integrity. I mean, you basically would have guessed this. And most of you probably know this BYD Blade battery, this very long one that is an cell to pack, or is made for cell to pack designs. I said last time when I was at this other conference, the battery pack of the BYD lithium iron phosphates Blade battery thing has the same energy density as a Tesla Model S with the cylindrical cells, which is impressive because you have LFP against NMC. The point is now that if you apply now this NMC into the cell to pack design, you of course add a lot of more energy. And there, the kind of common opinion was that these prismatic cells, like in the BYD Blade battery, do not work. It must be round, because only round cells provide the structural integrity that you need for the structure of the battery to make it safe as well, and to have the flexibility. The BYD Blade cell, you have basically one width of the battery pack, because it's like the cell is 1 meter, like, or almost 1 meter, so you can make a width of the battery pack of 2 meters, but you can't make it 3 meters, because then it doesn't fit on the road anymore, right? Whereas with cylindrical cells, you can basically play around as you like. And safety was really a key point. Also, in some other talks, there was a survey of experts in this field, and they basically said if you look for a new cell, the number one priority is the quality. And that brings us now to this topic of battery testing, right? Quality is where you need a lot of testing, and to make sure that then the cell works in the application, and the customer can deliver a battery pack that really fulfills all the requirements. So before the time is running out, I want to also touch a little bit on this topic of the speech that I gave there. I picked the safety of aged batteries. Why did I do this? I talked to a lot of people about the second life, about kind of how the battery needs to be used, can be used. And one ambiguous topic is there always the safety, because generally you think the battery is tested, the battery is put into a battery pack, and this protects it, and then it is used, and then it just doesn't really get worse because the energy content gradually reduces, so should be better, should be more safe. But it's not really clear. And I looked into some scientific papers, saw what was out there, and found that even there the findings were a little bit ambiguous. But generally, an uncommon theme was that the thermal runaway onset temperature is reduced for old batteries. So the older the battery gets, the earlier the thermal runaway starts. And it doesn't start when during operation temperatures, but there is really in some part several 10 degrees of change in the onset temperature. It, of course, depends heavily on the chemistry, on the additives, what you put inside. This leads to different aging mechanisms. Maybe I do a separate episode just about these aging mechanisms. And these lead to a degradation and then kind of this earlier thermal runaway onset temperature. On the other hand, the good thing about earlier thermal runaway onset temperature is that the thermal runaway itself is less violent. How I compare it is if you have an bow, like if you do archery, and if you have a later thermal runaway onset temperature, you draw the bow really up to your cheek, so the arrow flies very far. If you have an earlier thermal runaway, a lower thermal runaway onset temperature, you just draw the bow like a little bit, and then the arrow doesn't fly so fast. So there's less energy inside. In the end, it is then really important to evaluate the cells in the system to have an overall systemic view on this. You cannot just say the cell was tested before and it was used for 5 years, for 10 years, and now it's fine, I just continue using it, but really evaluate the battery under these new operation conditions and also under the view that the thermal runaway might start earlier. Okay, I'm out of time. I'm over the time already. I thank you for your attention. Next week, finally, the interview with Benjamin, the fourth part, will be released. I would have done it this week already, but I thought, okay, I give you this update right out of my brain, and look forward to hearing you next week again. If you're interested, sign up on the website www.batterytestingmentor.com, and have a good week ahead.